Multiple bonds are a solution to a problem in Lewis structures. They are the solution to the problem that occurs when there are not enough electrons to satisfy the octet rule. Now, I need to point out that there are 3 atoms that are okay with less than 8 electrons. Hydrogen, which can only take 8, oh my goodness, can only take 2. Beryllium, which is okay with 4, and boron, which is okay with 6. Assuming that you have a Lewis dot structure where the octet rule, you don't have enough electrons to fill the octet rule, and you're not trying to give 8 to any of these 3 atoms, then the solution to the problem is using multiple bonds. And the reason multiple bonds solve the problems of not enough electrons is multiple bonds allow for more sharing of the electrons. What happens when we don't have enough? We have to share more. Same way with atoms in a molecule or a polyatomic ion. So a single bond shares 2 electrons between 2 atoms. A double bond shares 4 electrons between 2 atoms. And a triple bond shares 6 electrons between 2 atoms. So sometimes we have to use those multiple bonds to share more so the octet rule is satisfied. So after you distribute all of your electrons and you realize that there aren't enough electrons to satisfy the octet rule, all you have to do is transfer a lone pair from one of the outer atoms to become a bonding pair between that outer atom and the central atom. And so you transfer that lone pair from 2 dots to become a line. If the octet rule is still not satisfied, then transfer another lone pair from an outer atom to be a bonding pair between the outer atom and the central atom. So let's look at an example of how this works. Draw the Lewis dot structure of the carbonate anion, which is CO3 2-. And what I'd like you to do is pause the video and see what you come up with. Okay, so the first thing we do when we do a Lewis dot structure is sum our valence electrons. Carbon has 4 valence electrons, and so there's 1 carbon, so that contributes 4 electrons. Oxygen has 6 valence electrons. There's 3 oxygen, so 3 times 6 electrons is 18 electrons. And then the -2 charge means we have an extra 2 electrons. We don't care where they come from. So the total valence electrons are 28. So we identify our central atom, which is carbon, because there's only 1 of it, and we arrange the other atoms to be on the outside, and then we draw a single bond between these outer atoms and the central atom. And each line that I draw is a covalent bond that represents the sharing of 2 electrons. So after I draw each bond, I've got to account for the electrons used. So I use 6 electrons. 6 from 24 is 18 electrons. So I have 18 electrons left. The next step is to distribute these electrons in the outer atoms. And I have 18 electrons. I notice that each oxygen needs 6 electrons, and 6 times 3 is 18. So we think, woohoo, we're done. All our oxygens have 8 electrons, yay. That's actually not the case, because we look at carbon, and carbon only has 6. And carbon is not an exception to the octet rule, so it has to satisfy the octet rule. So, as I said earlier, I said it and wrote it on the PowerPoint, what we want to do is we want to take one of the lone pairs on one of the outer atoms. It doesn't really matter which one, and we want to make it a bonding pair. So my cursor just happens to be on this top oxygen, so I'm going to take these 2 electrons here, this lone pair here, and what I'm going to do is I'm going to make them into a bonding pair. I'm just going to take those 2 electrons and make them into shared electrons. So I'm sharing more. So now I have a double bond. I didn't change the fact that I had 18 electrons, I just changed where they were. And so now the octet rule is satisfied. These outer oxygens both have 8. This oxygen has 8, 2, 4, 6, 8, and my carbon has 8. So this is an example of using multiple bonds when we don't have enough electrons. So let's go through another example. What I'd like you to do is draw the Lewis dot structure for cyanide. And here's its formula, Cn-. So go ahead and pause the video, and once you're done, start it again and we'll go over it. Okay, so again, the first thing we want to do is count our valence electrons. Carbon has 4 valence electrons, nitrogen has 5. Our negative 1 charge gives us 1 electron, so I have a total of 10 electrons. Now I have no central atom here because there's only 2 atoms, so I'm just going to connect those two together. Uh-oh, what am I doing? Okay, my pen is acting really weird. So I'm going to draw 1 bond between them, and so I'm going to subtract 2 electrons. Sorry, my pen is acting totally crazy, so I'm left with 8 electrons. Okay. Alright, now that if I distribute those 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8, if I were to do that, each atom would only have 6. So I'm going to have to draw another bond. So now gosh, I'm really sorry. Now I have 6 electrons left, because I had 10 and I used 4. And if I have 6 electrons left, I can satisfy the octet rule on one atom but not the other. So I'm going to draw one more bond, and now I've used 6 electrons. I have 4 left. Oh dear me. There's 1 electron, there's another electron. Oh my gosh, this is so horrible. And there's 1 electron, and there's another electron. So this is probably the worst Lewis dot structure I've ever drawn in my life, but I hope that you see that I had to do a triple bond because I only had 10 electrons. Now, one thing that I failed to mention with the carbonate is when we draw a Lewis dot structure of a polyatomic ion, what we typically do at the end is we put the structure in brackets, and then in the upper right hand corner we put the charge. So I forgot to do that for the carbonate, but here it is for the cyanide. And these 2 little dots, sorry, they were errors in my eraser, doesn't seem to work. So hopefully you can get what I'm trying to say by this.